9 objective says explain the importance of physical security controls. Now, when you think about security and network environments and devices, you probably think of network security. But do you think of physical security? And when you do you think of maybe just getting access to a facility? Well, you wouldn't be incorrect by stating that, but it's not just that. Take a look at this particular area under physical security controls, environmental controls. Things that we're looking at here for a level of protection is HVAC, hot and cold aisles, and fire suppression. Now, all these play a vital part of keeping your systems available when your users need to have access to the resources. And when you think about HVAC, do you really know what HVAC is really being provided for environmental controls? Well, yes, it does provide heating and ventilation, but it's so much more that goes in hand with HVAC. Let's take a look at this. HVAC stands for heating, ventilation, and air conditioning. So like we're saying, it does provide, obviously, some temperature controls. Now, what we're seeing here is some recommended ranges that we're looking at for your environments. And keep in mind, here we're looking at HVACs, these big air handler systems that's going to manage or keep a specific range of temperature in degrees. 72 to 76 would be an ideal range. So that room is going to be housing all of your servers that are going to be housed in locking cabinets or server racks. They produce a lot of heat. So you got to have these very powerful air handler systems to generate a lot of cold air to keep it at a normal range. They're also going to be responsible for keeping that humidity in check. Now what we're looking at here, that relative humidity has a range between 40 and 60%. So your HVAC is going to be providing temperature control, humidity control. Once again, you have your temps too high, well, your equipment's going to start malfunctioning, shutting down. That's not a good scenario there. If you have your environment where all your systems are housed, if you have the humidity where it's too low, let's say below that 40 percentile, you're going to have static electricity, ESD. Too high, then you're going to have the whole sweating of those devices internally, where you're going to have corrosion, short circuitry inside. So obviously, we probably think about that for HVAC, but don't forget that HVAC system is there to also filter the air. These little tiny particles of time can also, over time, degrade the performance of your devices. So they're going to provide some air filtration, and these systems can be there monitored locally on site, and they could also be monitored remotely. This is where those sensors come into play. They can detect when these devices are operating at optimal ranges, or when they have like a hiccup and they're no longer providing some sort of level of cold temps, or if there's some sort of level that there's some indications that they need to change a filter. You can do this locally as well as remote. So they're now part of that infrastructure, and we'll probably see this if you haven't already looked at it in regards to how HVAC systems lie within a SCADA environment. Now they are part of that infrastructure now that we're looking at for our local area network. So HVAC, now what goes hand in hand with HVAC is our hot and cold aisles. These two work synonymously with each other. They work in conjunction. Your hot and cold aisles are vital to making sure they do provide that optimal temperature range. Your hot and cold aisles are based off of the strategically placed server racks. You know, the forward face and the front side of those, where you're going to have all of your systems and servers. That's the cool side. The cold air is going to be blowing in through those server racks, the front side of those servers, blowing through the server racks and out the back side of the server racks. That's your hot aisle. Now, a lot of times your hot aisles have some sort of ventilation system, so it'll suck all the heat out and recirculate the cold air throughout. This is what's going to allow us to give us a normal range. So the cold air travels in front, pushed through the server racks. The hot air travels out back side of the server rack and exhausts out normally, but there's a normal process of keeping a normal range. And it's designed to assist the air circulation in your server room through and with your HVAC system. And not to mention that, you see in the picture here, you are also going to have these little perforated tiles or tiles where they actually have more airflow. Those are also brought in with the whole idea of HVAC and your hot and cold aisles. And lastly, we're going to look at fire suppression. There's different ways of suppressing fires, obviously. Some of you may have actually, if not all of you, have gone through these different classes of fire extinguishers, the portable kind, things, we have those strategically placed throughout a facility. Classes A, B, C, D, and K for your kitchen fires, excuse me. Your Class A is for your ordinary combustibles. Class B is for flammable liquids. Class C is for electrical equipment. And Class D is for combustible metals. Now, the difference in those obviously is going to be the type of fire that's being generated from. I always had a little short rendition. The Class A, things that we find that you would want to use a Class A fire extinguisher on. Paper, wood, when you burn those, they create ash, A for ash. B, oils, gases, gasoline, you like those. Flammable liquids, it goes boom, boom for B. Class C, servers, computers, appliances, those electrical components, everything's in regards to that. It's going to be relying on circuitry, so C for Class C, circuitry. And then your combustible metals, magnesium, sodium, as I give examples here. I always tie this with metals, didn't know metal burn, didn't know the Class D. Any little tricks to kind of help you along the way to kind of help remember these things. So those are your portable fire extinguishers. You're also going to find fixed systems, those that you're going to find in larger environments or larger fires. Those are usually going to be water-based or chemical-based. Water-based, probably things we're already familiar with. Your sprinkler system, they're actually going to be suppressed fires, obviously releasing tons and tons of water. Then you're also going to have your chemical-based. Now, they too are going to be within a fixed system, but instead of releasing water, they're going to be using chemicals. Some common ones we see here, they're going to fall into this whole inert gas area are halon, HFC 227, and then FM 200. These are all considered clean agents. Now, I say clean agents. Halon's been around for ages. They've usually started going around as a replacement for those. Depending on environments, they'll look at that as like maybe health concerns, environmental concerns. It's a non-flammable gas, but you usually have some better replacements, such as HFC 227, which is a part of FM 200. Those are clean agents. They extinguish the fires by suppressing and absorbing the heat. It's a combination of chemical and physical mechanisms. They're able to do this without affecting large scale the available oxygen in the air. It's colorless, odorless, and electrically non-conductive, unlike halon. So you can move any one of the three elements in a fire, the heat, fuel, and oxygen. If you take one of those elements out, then you're no longer going to have fire. So your clean agents are there to absorb the heat. And they could also be found in environments where you have a populace, your personnel. So we're able to have these clean agents in an environment where you do have personnel. If they happen to be in the area when it's discharged, it's going to allow them to escape safely without, once again, making them be more endangered to not just the fire, but also the fire suppression agent.